welcome back guys for this part. In this part, we'll graphically analyze the force or how force changes with the displacement. This is what we'll analyze in this part and how to find out, and we also going to see how to find out the work done when we have the force displacement graph. So we're going to see this thing in this part. So let's have a look. So, work done by area under force displacement graph. As we can see from the figure, that this figure shows that the force displacement graph is a curved line. This is the curved line shown to us, and so therefore what we can say that force is dependent upon the position. That means force is a variable force. So let's start with the thing that let a body whose initial position is xi, this is given to us as xi, and acted upon by a variable force, okay, and consequently the body acquires its final position xf. Okay, when the body is at the initial position, if we look at the figure, if it is at the initial position xi, the force is acting at this position is this much amount of force which is acting on the initial position. Now if body reaches to final position over here, so the force which will going to act on the body will be this much amount of force will going to act on the body. Now if we see that let f be the average value of variable force within the interval dx from the position x to x plus dx, that means that let's say the initial position of the body in between the motion, the initial position or the position we are considering at any moment is x, and after that it has the displacement or its final is x plus dx. That means after the displacement dx, let's consider this, that this is the displacement dx. For that displacement, let f be the average value of force. This is being given in the figure that this is the average value of f, and so therefore the work done will be the area of the shaded strip of width dx. So this is the area. This what exactly it means? This is the area. This is the area. This area of the strip will show the work done. That means what we can write this as dw is equals to, that is the smaller work done in displacement dx, or for displacement dx will be equals to force, that is this average force f dx. So this is what exactly it means, that is it is the area. Now so the total work done on the body in displacing it from initial position xi to final position xf will be equal to sum of the area of all these strips between xi and xf, that is that as many strips we can consider. So those strips will going to, if we add up these strips, so that there will be many strips between them, but as for the convenience we are showing these are the strips. So these are the strips. So if we are going to add as many as strips, like this is the strip 1 and this is the last strip, so if we are going to add the area of these strip, so this will going to give the area under this curve. So therefore what we can say that total work done will be equal to integration of the smaller work done for the displacement dx, taking the limits, that is the x initial position and the final position xf. So this will comes out to be f dx, or integration xi initial position to xf final position f vector dot dx vector. That is the displacement is also a vector. So therefore what we can say that the area of the strip, or else we can write this as work done is equals to integration xi to xf area of the width, or area of the strip of width dx. So what is the conclusion now? So the conclusion is the area under the force displacement curve with proper algebraic sign. The sign should be considered represent the work done by the force. Okay. Now moreover with the change of, moreover, we have to see that the work depends upon the frame of reference. That means with the change of frame of reference, okay, frame of reference is the inertial frame, it should be inertial. Okay, the force does not change, that we know, that if we'll change the frame of reference, if we'll move from one inertial frame to another inertial frame, force won't change, but displacement will be different. Like if we look at from one inertial frame, the displacement will be something else. If we look at from the another inertial frame, displacement will be something else. So therefore, it depends upon, the work done depends upon force and displacement, so the work done by the force will be different in different frame. So we come up to this conclusion. Like if we look at the example, that if a porter with a suitcase on his head moves up a staircase, so work done by the upward lifting force relative to him will be zero, because the displacement relative to him, or else the displacement of the suitcase relative to him will be zero. So but with, while if the person is standing on the ground, so with respect to person standing on the ground, its work done will be mgh. So this is what exactly the work depends upon the force. Now let's look at the example. A 10 kg mass moves along the x-axis. Its acceleration as a function of position is shown in the figure. Okay, what is the total work done on the mass by the force as the mass moves from x equal to 0 to x equal to 8? So this is the AT graph given to us. This is the acceleration time graph given, acceleration displacement curve is given to us. So what we can say, that the mass given to us as 10 kgs. So what we have to find it out, the work done. So what do we know, that the work done is equals to area under the force displacement graph. But since acceleration displacement graph is given to us, what we can say, that if we're going to find it out, the work done under the, or if we're going to find it out, the area under the acceleration displacement curve, and if we'll multiply it with the mass, then we'll get the work done by that force, because force is equals to ma. So therefore the area under this curve will be this, that is the area of this triangle. So what we can say, let's say that this is triangle OAB. So work done is, so therefore area of OAB will be equals to 1 by 2 into base. What is a base? It is 8 into 10 to the power minus 2, because it is given in centimeters, into the acceleration. It is, for this it is 20. For this it is 20 into 10 to the power minus 2. So if we look at this thing, this will comes out to be 4. Okay, this will comes out to be 4 into 10 to the power minus 3. Now this is the area we got from the AX graph. Now work done will be equals to mass into area. Okay, this will comes out to be 8, not 4. 4 yes. So 10 into 8 into 10 to the power minus 3, this will comes out to be 8 into 10 to the power minus 2 joules. This will be the work done. So therefore for this, option A should be correct. Now let's look at the another example. Now the graph between the resistive force F acting on the body and the distance covered by the body is shown in the figure. Now the mass of the body is given to us as 25 kgs. When is the distance covered by the body is 5 meter, the work done will be, okay, work done will be means work done by this resistive force. So So therefore what we can say that it will be area under this curve. Okay, so therefore what we can say that the work done is equals to 1 by 2 into base, that is 4, into height, that is 20. So this will comes out to be 40 joules. Okay, the option B should be correct for this thing. So guys, if you have any query, so you can log on to our website www.askIITians.com, and here you will going to find many options, and here you have to choose. Among that options you have to choose ask a question, and upon clicking on that you will going to see a discussion board, and on the right hand side you will going to see an ask expert. Here you have to select a category, like if you want to select a category in the physics like general physics, so you have to select general physics. Now here you have the text box, there you can write anything to get answer from the expert. And you can also attach image by clicking on the link attach image, and after that you have to click on get answer to get answer from the expert, and we experts will going to revert back in 24 to 48 hours. So guys, in this part we have learned that area under the force displacement graph gives the work done. Now what we have in the next part, this is what we have to see. Again, stay tuned for that.